New set of notes where we are transforming them. That means moving them up, down, left, right. Sometimes we're pulling them up and stretching them up. Sometimes we're pushing them down and making it look fat. So the equation, I need a name again. Let's see. Paul Bunyan. Who was he? No. You never heard of Paul Bunyan?
No, have you?
Yes. There's a statue of him and his blue ox in Michigan. As you go up to the Upper Peninsula, there's a city you go. It's called, I interviewed there. Manistee? No. I don't remember where I interviewed up there. And as you enter in, there's this giant Paul Bunyan with a plaid shirt and an axe and a blue ox.
Yeah, I remember now.
It's not real,
Not real good.
but it was a story about Paul Bunyan would go out there and chop all the trees. And so now what we are doing, we are still graphing, but we'd go graph, expose, move by shifting. Shifting just means move them around, okay? That's a good enough title. Making sure, okay. And the date is still the same. I always forget, even though I say it's the same, I forget. 3:18. And this is still 4B. Okay. So now, look at the equation. You see how there's a lot more to it? We started out with just this part right here, except without the minus k. We did b to the x. That's what we had before. But now we're talking about some transformations. We're moving it. The easy one is this one right here. The k number on the end of it tells you how much you're shifting it up or shifting it down.
Positive.
If it's positive, it goes up. If it's negative, it goes down. Now, another one is up here. The x is minus h.
H is a positive shift.
Okay, if you say a minus a number, then it goes to the right. If it goes plus a number, it goes left. Then they talk about the a, the number in front.
Hey, sir, I don't think we can see.
You can't see it up there?
Are you doing the notes?
No, I was doing shading. Shading didn't help?
Never mind.
Oh, shading didn't help. A little bit. Not very much, though. Shading, it's it's highlighter. Didn't work that well. So I'll go back to the regular marker. So look at the H. The H is considered a vertical shift. Vertical. So I'm going to write the word vertical, but then to make it sense for most of you, we're either going up or we're going down. Shift up, shift down. And the K, wait, I just messed up. I wasn't listening to Tristan. He said the K, I'm sorry, I wasn't looking here. This is vertical. Up or down. Yeah, I got to do the H. He put the H first. I did it, the K first because it was easier. And they're telling me, don't do that. The H is our left and right. So I'm going to put the word horizontal shift. Horizontal shift. But you'll know it as left or right. And now they're going to tell us what. I don't like doing it this way because it gets kind of complicated. If your H is positive, if the H is positive, you're always going to have an X minus. So if the number after that minus is positive, then we know we're going to the right. So that means shift right. I wonder what they had. Plus shifts. Oh, plus shift, minus shift. So If H is, this is H we're talking about. If H is positive, it's going to go to the left. Hey, I'm trying to figure out what she's doing here. Plus shifts left, negative shifts.
Hey, sir, you got this?
Yeah, I think so, right. It gets confusing because I don't do it this way. I don't pay attention to this. I don't go x minus a negative 2, x minus 4. I don't tend to say, oh, this is my h right here. This is my h right here. It gets too confusing. So after I write these notes, I'm not going to do the h this way. I'm just going to look at this. X plus 2, that's this one right here, will go left. X minus 4, that's this one here, will go right. I don't do the h's and say, oh, what is h? It gets kind of confusing. But the k is okay. If we're doing the k up and down, that's easy. And Tristan already said it. If your k is positive, it goes up. If the k is negative, it goes down. That's easy. It's the H one that causes people a problem. If A is negative, doesn't matter what kind of number it is, if it's negative, the function is going to flip. It's going to turn upside down, and it's going to be over the x-axis. X-axis. Doesn't mean anything till you try it. Now, if the absolute value of A, forget the negative now. Who cares about if it's negative or positive? So just say what A without the negative sign. If it's bigger than 1, do you remember what it did on 2 to the x versus 3 to the x? The bigger number did what? It made it more steeper, right? That's called a vertical stretch. So if you got a number in front of the B and it's a number bigger than 1, it's going to get really stretchy. And I'm not going to do these a lot. I'm not going to make you necessarily be tested on that. I'll let your pre-cal teacher do it. If the A is less than 1, then what happens is it becomes really fat. So there's 2 ways you could say it. You could say a vertical compression, or you could say a vertical shrink. I'll use shrink since they both start with S's. Okay. That happened with the parabolas too, guys. I don't know if you saw that when you were looking at graphs of parabolas. If you graphed y as 2x squared versus y is a 4/5 x squared, what would happen, this one would be really skinny. And this one here would be really fat. In other words, this got stretched up, this one got pushed down. So it shrunk, so it makes it fat. If you pull something up, it gets skinny. If you push something down, it gets fatter. That's the same thing. If that number is bigger than 1, it's a vertical stretch. If it's less than 1, it's a vertical shrink or vertical compression. Just depends on what book you're reading. Compression is the same thing as shrinking. It gets kind of confusing, but let's look at this. All they want us to do is see what's happening. What time did the bell ring?
2:29.
We might only get a couple done here. So, what time does it ring?
2:20.
Oh, what time is it right now? Yeah, 2:20. No, it's 2:16. So look at here. This is the one, he wants us to identify the parent. Okay? Well, the parent to me is this piece right here. A, the parent, is what we did on the other page. Y equals to 3 to the x. Okay? So if you graph that, you know what it looks like because we already did it on the first page. But B wants us to look at the transformations. So forget the parent. Parent doesn't matter anymore. If I had to graph this one, somebody needs to tell me what this plus 5 does. There it is. What's that plus?
Pushes.
No, it doesn't switch nothing.
It puts 1 under.
It's a K. It's a K. What's a K mean if it's positive?
Negative.
No, look up there. If K, it shifts up.
Vertical.
Yeah, vertical shift up, right? Vertical means it goes up. So I'm just going to write, wrong place. If K is a 5, it shifts up 5 units. And we won't graph them today. We're just going to talk about them, then we'll finish this up. Okay, look at here. The parent, do what? Yeah. Sorry. I don't know who I'm racing. There's nobody else that we're racing. All right. Now this one has two. I'm going to use a shading. Hopefully it'll shade for you. You can see it. This here is a transformation. So is multiplying by a 2. So I'm going to write the parent. The parent, if I ignore what I just highlighted, that would be f of x equals to 1/4 raised to the x. We did one like that. That's the father, okay? But because we did 2 transformations, the children look a little different, okay? So part B, what does the x minus 1 cause it to do?
X.
No, that's not even an answer. We're either shifting up or down, left or right, or we're stretching or whatever.
Down.
This one, does the number, isn't that called the H number? Does H have to do with up and down? Or does H have to do with back and forth?
Side to side.
Side to side. Horizontal. So which way am I going? Left or right? I'm going to the right. I don't know how you could see that already. It shifts right. How many units?
3.
No, it's an x minus 1. It's going to be 1 unit. And it gets people confused because they go, oh, but sir, there's a minus here. But the H is not minus. The H is this number right here outside of the minus. So it's really a positive H means I'm going to the right. It gets confusing. Just think, whatever you see, think opposite. You see x minus 1, think right. How about the 2? The 2 times. I'm going to put times 2. What is this?
Right.
No, that doesn't move left or right.
Oh, my bad.
That has to do with either shrinking or stretching.
Shrinking.
I don't think it shrinks with a big number.
Oh, wait, no. Gross.
If that number is bigger than 1, and it is, it's going to be a stretch. So that's going to be a vertical stretch.
Are you a grower?
Matter of fact, we can actually say, how much will it stretch? There's a 2 in front. It stretches 2 times of what it was. Stretches 2 times.
You never answered it.
I didn't hear you.
Wait, oh, now you.
Oh. I mean, I hear you mumbling, but I didn't know what you asked.
I was talking to Chavadine.
Oh, I think he's asleep.
He's right here.
Oh, okay. All right. You good on this one? I know I was moving already.
So I think we have 9 minutes.
Okay, we're good. Because all we got to do is pick up the papers and put calculators away. We're okay. I'll probably stop after these 2. Because I don't need to graph any right now. I want us to think about these. All right, look over here. I'm going to try to highlight it, see if it'll highlight it. There's this. Oh, come on.
Today's Orozco's birthday.
Whose?
No, it's not.
Orozco's.
Don't listen to this guy.
Don't listen to him. He doesn't know what he's talking about. Okay, look at here. We got this plus 7. We got this plus 2 with the x. And we got this minus out
I
front.
had to tell my daughter.
Okay? First of all, let's do what the direction says. Let's do the parent. Before it moves, that's part A, It was f of x equals to a 4/3 to the x power. Now, what happens with the plus 7?
It shrinks.
No, it's on the outside. It has nothing to do with shrinking or stretching over there.
You're right.
That's the K number. This is the K number. What's the K number spot before?
A vertical.
Up or down, right? So it goes up 7, right? Okay. What does the next thing is the H number up there. I see an X plus 2. The H has to do with left and right. Think opposite of what you see. If you're adding 2 to the X, it's shifting which way? No. No, it has to be left and right. Shifts left. Left 2 units. And again, the reason it's left is because think of it as x minus a negative 2. That becomes x plus 2. So the H is negative. So that meant we are going left. Was there another number? Oh, yeah, there's a minus there.
We're growing.
There's a minus. What does this minus do in front of the whole thing?
Shrink.
What does it? What does it do?
It shrinks.
What am I doing?
Swinging your arm.
Yeah, I am swinging my arm. I'm flipping it upside down.
Oh.
Yeah. That negative right here flips over the x-axis. It turns the growth upside down. It turns the decay upside down. That one's a growth, by the way. It'll make more sense once you're graphing them. You'll see it. You go, oh, yeah, it did do that. Matter of fact, I wish they would give us the same problems that we're graphing so you can see them. But that's okay. Okay, what are my transformations now? I got a minus 2 here. I got a minus 4 up here. I got a 1/2 out here in front of the 5. So my A is a 1/2. The parent, oops, wrong one. The parent is f of x equals to just a 5 to the x. 5 to the x, just this part right here. So part B, let's see how many of you get it right this time. Tristan, think before you say something.
Yes, sir.
I got the K is equal to a negative 2. What does that minus 2 cause the function to do?
Go down.
He did it. He did it. What did he say?
Go down.
It shifts 2 units down. Very good, Tristan. All right. I want the same brilliance right now, okay?
Sir, I guess.
Well, you only had a 50-50 shot.
No, I told him to answer.
So now I'm looking at my x minus 4. What does the x minus 4 cause it to do?
Up.
We already did the up and down. Why would it go up
Oh, wait,
again?
you're right. It's to the left.
No, it's always the opposite. It goes to the right 4
I did on myself.
units.
It's 4 units to the right.
And then I got that fraction of a half being multiplied in front. So it's being times a 1/2. That 1/2, by the way, is less than 1.
Oh. 0.5.
Yeah, but still less than 1. What does it cause the function to do?
Shrink.
It does. Vertical shrink. It gets wider. It gets wider. Not skinnier. It gets wider. And let's call it a day. Make sure your name is on your packet. Both pages. Bring it up. All All right, we're going to finish this up. We're going to graph some of these. In the first couple, I want to go slow. Because when we start talking about our exponential growth function, yes, it's true. They all have this asymptote. Why not drawing? I don't have a color. They all have this asymptote. And they're either going to go, you're going to ride the asymptote, and they're going to go up forever like Superman. That's a growth. Or it's going to start at the top, and it's going to fall down to the asymptote, ride the asymptote. But that asymptote can change places. It can go up, it can go down. The y-intercept, which I found it when x is 0, can go up or it can go down. It can also go to the right or to the left. It's not up there?
No, it's not.
I wasted all this talking. If it wasn't for Luke.
That's 5 points, sir.
Huh?
That's a Jolly Rancher.
If I had some, he would get one.
I know, sir. Just
It is on. I don't know why it shows that it's on.
It's probably broken.
No, it probably went off of the Apple TV. Probably turned off. Let's see.
I think
It
it's
died.
broken.
No, yeah, it didn't. It kicked me off. The Apple TV kicked me off.
I rebooted it.
Well, now that's on, so I did probably have to do that to the projector. Oh, wait, no, there it is. Magic. Technology is great, except
I
when
can't
it
see it all.
doesn't work.
Where were you at?
What are you talking about?
Where are you at?
We're here. Yes,
I'm not.
we were here, and then all I did was, since we've talked about what A and what H and K do, what I was trying to tell you is that I drew a growth and I drew a decay. The blue one's a decay. And I'm just going to draw a parent one that we drew like yesterday. Yesterday we drew, not yesterday, but the other day, we drew like y equals 2 to the x. And it looked something like this. And this point here is 0, 1. That's my y-intercept. And the asymptote was the x-axis. But when we start applying h's and k's and a's, then everything can move up, down, and don't be surprised if the parent now looks like this,
A monkey.
where the asymptote moved up 5 units. And if the asymptote moved up 5 units,
So did
then it's the y-intercept also probably went up 5 units. So it used to be at 0, 1, but now it's probably up at 0, 6. Because it has to go up, it went up 5. So we'll do this real slow. This first one for sure. It actually is the easiest one because I see the parent. So write out the parent. Y equals 2 to the what?
To the X.
Very good. No, just say x. That's the parent. If we say plus 5, then what we're doing is having to say, oh, the parent just moved left or right. Because that number that gets added or subtracted to x is considered the h. And the h, I know you don't see it, but in disguise, the h is a negative 5.
It's a positive.
No, it's not. Because remember what it looks like in our notes up here. The formula. It's always got to be written as x minus a number. So what happens is when you look down there, the only way that I can make that an x minus a number, I literally have to look at it as that x plus 5 is really x minus a negative 5. Because you know what a negative times a negative is?
Positive.
The positive. See the positive? But in reality, you have to realize that the h is the negative 5. And if the h is a negative 5, it moves which way? Please look at your notes.
To the right.
No,
Wait, is it a negative? Oh, it's a negative, so it's to the left.
it moves left. So I want you to say shifts left 5 units. So here's the thing I tell students. Don't worry about this. Look at this and say to yourself that whatever you see, I see a plus 5. When it's with the x, think opposite. It doesn't go right, it goes left. This is the only time you think the opposite. Whatever's happening to x, think the opposite. That's a little easier than trying to break it down and say, what exactly is h? Who cares what exactly h is? Just look at x plus 5 and say, left 5. What if you saw x minus 2? What would you think?
Plus 2.
You would think right 2.
Yes, sir. Can I go rest from now?
Yes, I did promise you. So let me get rid of this. I don't need this stuff too much, okay? Well, so what I'm going to do, first thing I'm going to do, I'm going to graph the parent. I'm going to graph it with a color I don't care about right now because I remember it from yesterday. We did 2 to the x yesterday. Feel free to look at your notes. That was number 1. That was number 1 from the other day. So I remember that when I graphed y equals, come on, draw, y equals 2 to the x, I remember my table that when x was 0, what was y? Do you remember the answer? It's always the same when x is 0.
1.
A 1. And I don't really care about the numbers to the left because you and I both know that this is a growth, right? So when it's a growth, it's going to look like this. From the left, it rides the asymptote. Then it's going to go through the 0, 1, and then it's going to climb. Remember that? So I'm doing it in yellow because I don't usually keep my graphs in yellow because it's too light. But that's my parent. So you got your calculators, right? Let's graph it again. Let's get it ready because I'm going to be putting the new function with it so you can see. All right? So, matter of fact, we're going to do them both in the calculator at the same time so we can see it. So, end behavior. As x goes towards infinity, which means that's a big number to the right, on the blue equation, as x goes bigger and bigger and bigger, what do the y values do? They go bigger and bigger and bigger, right? Infinity.
So what's that? CO.
It's not a CO. It's in parentheses, 0, comma, infinity.
That makes sense.
Then, as x goes to the negative infinity, that means you're going this way forever. You already got the answer, Laura? It's approaching 0. Will it ever get there?
No.
Does it keep getting smaller and smaller?
Yes.
But it'll never get there.
Yeah.
0. And the y-intercept, my new y-intercept was what? Thank you, sir. Okay, good idea, good. 0, comma, 32. Absolutely. Now, I did that 2 ways. I found it by using 2 to the 5th power. We also found it in the calculator, right?
Y equals 0.
Already wrote that.
Oh.
All right, I want to do the other one slow too, okay? Ready?
Yeah.
Okay. Is that minus 2 called? I'm looking up here.
B.
H.
Nope, it's not.
X.
It's what?
X.
A.
It can't be x. X is a variable. Has to be an h An H, an A, or a K.
I said H.
But it can't be H because it's not next to the X.
Okay.
It's the K. Go back and look at it. You'll see. If I see him again or hear him again, you're going to lose it.
That's right.
Well, that's fair game, right, Tristan? He got you once, and well, that was Michael, actually. K, K, K. What does K do? Up or down. So what do you think -2 does? It says when it's negative, right here, it goes down. How many units down does it go? I heard it. I got to find it again. I'm trying to find it.
We're not doing it like
Page you want to see. 5. The other one has a little more craziness.
What up?
Can you go back?
Sure. So now this function is not a growth.
It's a decay.
How do you know?
Because I just know.
I said it's not a growth, so obviously it has to be a decay. The parent function, guys, I'm going to always tell the parent. I'm going to look at the parent. Parent is the number that has the x power. What number has the x? 1/3 has the x. And that's my b then is 1/3, which is less than 1. Therefore, it has to be a decay. So I know it's going to look like this. It's going to fall, right? It's going to fall like that. And then I'm going to do the, in yellow, I'm going to do the parent again. Because I sort of kind of remember it. We did a half. I don't know if we did a third, but they're the same. The parent still has a 0, 1 y-intercept. And I know that as it falls, as it approaches to the right, since it's falling, it's going to ride the asymptote forever and ever and ever. I don't need a number, guys. I don't need to go to my calculator and get a number over there because the numbers are going to be crazy decimals anyway. So just pretend that we know the numbers and we're close to the y. We'll call this the asymptote, right? But I do need a number to the left. So maybe I'll just pick on the 2. Because I can do the math for the 2. But you could also use your calculator. Because you can go to a blank screen on your calculator, just like I can.
Lisa, can you go up a bit? I don't know, thank you.
Yeah. So my table that I have for the parent right here, I'm doing the parent right here. Table. We already know that when x was 0, I get a 1. And I need a negative number, and I put this, it's a -2 right here. So if I want to do the math, I would just say, okay, 1/3 to the -2. Now, before I get the answer, do it in your calculator. Go to your calculator, do a parenthesis, a 1/3 to the -2 power. And if you get a number, don't say it. Just hold your screen up to me. So I want to see the screens. If you can get a number. If you know how to get that number. 1/3. I think you have to put in a parenthesis. But I could be wrong because the Inspire is a smarter calculator. Anybody? Who's the first one? Nobody? Tristan. You're on a roll of passing. Don't ruin it. So even they don't like it.
That's very tiny, though.
Beautiful time. They heard me. I need to see the screen. Who's got it? You got 3 people. Only 3 can type that in right?
I typed it in.
Oh, but do you have a number?
No.
Well, then you didn't type it in. Because if I was to use my calculator, so I went up, -2, gave me the 9. And that's all I need, because watch. There's that curve going through 0, 1, and I'm going to go up to the -2, 9, and I'm going to just, that's it. There's my parent. I spent too much time just doing the parent. you should just be able to go to the calculator, graph it, and plot a couple points and pretend where it goes, you know. The question is, we have one transformation. This minus 2. In the notes, if we go back to the other page, what letter of the it's outside of everything, minus 2. So what we say is K is a minus 2, a negative 2. Now go back to that other page. What does it say when K is negative? How does this function change? I know it's a lot of work to go back and think. I know you don't have it memorized. Put these cards away. 2. So it shifts down 2. And this is the only transformation I have. So go back to my picture. It's in yellow. What do you think happens when this thing shifts down 2?
Goes into the negative.
It does. The asymptote moves. How far down does the asymptote move?
So like negative 2?
Exactly. It was at 0. Now it's at a negative 2 for the one that I care about today. There it is. Y, I'm going to write it down. Y must be a negative 2, since Elisha exactly knew for sure. How about that point at 0, 1? Where do you think it goes now?
Down.
How far?
Negative 2.
Goes down 2 to a negative 1. Luke is right. It goes down to the negative 1. How about that point over here at negative 2, 8, 9, or negative 2, 9? Where does that go? Down to 7. Nice. Goes down to here. Wait, yeah, somewhere I'm off. Can't see. 1, yeah, it goes here. So what's going to happen is the function is going to fall from the top again. Oh, shoot. I'm a terrible artist. I need to take art classes to become a better math teacher. Fall down from sky. Cross that point that I just moved down to 7. Go down to the point at the negative 1. Head to the asymptote. Ride this asymptote all the way forever and ever and ever. So there it is. There's the graph. And what you did was you shifted this yellow one, you shifted it down. So far we've done a left, we've done a down. Can you imagine how hard it gets when we do a left and a down? Gets kind of crazy. But anyway, I'll try to keep it simple for you on a test or a quiz. I'm not going to make you do some of these are a lot harder than I would ever put on a test or a quiz. Number 1 or number 5 and 6 that we did are perfect. And maybe a couple more here, but if you can get better than that, that's great. So look at the blue one. What's the domain now? It still stays all real numbers? That's kind of like cheating if it's always the same. So I'm going to write all real numbers.
That's the thing we do the R for, right?
Yeah, you can use the R. You don't have to copy me. I'm just wanting everybody to know that you could use the fancy R. You could do all real numbers. Or you could do from negative infinity to infinity. They're all the same. I show them all because you never know the quiz question on Canvas. You never know what they wanted, how they wrote it. So I tried to prepare you for everything. The range. It changes, guys. How low can it go now?
Negative 1.
-2. The asymptote moved to -2, and I think, who said it? It was Elisha who said it was y is a -2. So we go to -2. How high will it go? It sure does. Do you think the left and right end behavior changes as x goes to the right? Look at it. What are the y values as you go to the right, to the right, to the right?
Positive.
They never are positive. Not 0 either.
1. No, they're negative 2, my bad.
Guys, as you go to the right, it follows the asymptote.
It's negative 2.
It's a negative 2. One of those ways is always the asymptote. Always, guys. How about to the left? That's this negative infinity. Left. How high? No, 0. No. How high is it going?
Infinity.
Inf-
Negative.
No. That means going down forever.
Positive infinity.
Goes up. Positive infinity. I just write infinity. Now, the y-intercept changed. And I'll be honest with you. I don't think I evaluated it, did I? Oh, yes, I did.
Negative 1.
I know I didn't do it. Is it a negative 1?
Mm-hmm.
Can you prove it to me?
Because it goes down 2.
Oh, yeah, you're right. You're too good.
No, I'm not.
Okay, but I think you were all right, man. 0, negative 1. I think you did good. Okay? Guys, if you don't like yourself, don't expect others to appreciate you. You always have to look in the mirror and have to like yourself. Now, if you don't like everything you do, you can change. I'm telling you guys, it always starts with your heart. It doesn't start with anybody else.
So can I go to the restroom?
Is the pass up there?
Yeah, it is.
Go ahead.
On the side.
Now, you're responsible for 7, whether or not you get it done or not. If you're going to take 20 minutes, you're going to be probably missing 7 and 8.
That's a red alert.
All right. No, I haven't given anybody a red alert for taking too long. Well, well, it's excessive, right? But hopefully he'll do it right.
What?
That you'll be quick.
Oh, yeah.
So look at what transformation do you see jumping out at you?
What time is it?
Transformers.
Plus 1. It is 146. So what does that mean? That's the K, yeah. That's the K. Up 1, right? But there's a new transformation here. There's a number in front of the 3 to the x. Because y equals 3 to the x is the parent, b is equal to 3 greater than 1. It's going to be a growth. But there's a number in front of that b. What do our notes call that? Go back to our notes.
It was 0.
It's an A.
Oh, I thought it was a 0.
It's an A. That's A. Is it negative?
No.
No. If it was negative, it would flip upside down. But it is, A is equal to a half, which is less than 1. What does that cause it to do? Now, I'm not looking at the notes. Go and look at the notes. What happened when A is between 0 and 1?
0.5.
No, I didn't ask you what's between. Read your notes. What does it say that A makes it do? A vertical something.
Shrinks.
A shrink.
It's not a grower.
Not a grower? He's right. It says vertical shrink.
It's a string.
Shrink. Shrink. It's a weird word. Shrink. Of 1/2. That means picture a giant pushing it down, making it fatter, because it's making everything go down so it spreads out this way.
Yep.
Let's look at this in the graph before I go to my picture. All right? Let's go look at the graphing calculator. As X, and some of you are just sitting there, I'm worried about you. You'll still get a good grade if you keep it up, but then when I give you a quiz next time, maybe you won't know what to do. As X goes to the right, what do the Y's do? Look at it. You guys have not said nothing. Say something.
0.
Say something that makes sense. It grows. So what value do I say it goes to? How high is it going? Infinity. And then this is to the left. So the Y's. How low is it going? To the 1. Y-intercept, we found it on the calculator. Was a 0, comma, 1.3 is good enough for me. If you were to be really smart and say 0, 1 1/3, I'd call you a genius.
Is 0.
Asymptote, y equals 2?
0.
Is not. Look at the blue line.
1.3.
1. Right? Phew. Aren't these a little harder when they move?
No.
All right. Tell me what the parent is on number 8.
The X.
Nope, that's not the parent.
The 3 and 4.
Y is 3 over 2 to the
5.
x. Nope, we only use the x. The parent doesn't shift left and right. The parent doesn't shift up or down. The parent is the same as we did on the other day. Is that a growth or a decay? No, it's not. If the b is 3/2 and it's greater than, that's terrible writing. The b is 3/2, which is greater than 1. It's a growth. What do I know about it? What about the new function? What transformations are there? What is this -5 called? That's my k. What does it do?
Shift up and down.
So which one does this one do?
Down.
Shift down 5. What does the, okay, here it is. Now, I'm going to see who was paying attention. I'm looking at x minus 4. Don't say nothing yet. X minus 4 has to do with the h. Right? That means left or right. Just tell me, which way do I go?
To the left.
To the right.
It's always the opposite. This one goes right. Shifts right 4 units. Always think the opposite when it's with the x. When it's with the x, it always does the opposite of what it looks. And the reason is h is a -4 because it's written as x minus a -4. Wait,
So what time is it?
I lied. Hold on. Got to erase my lie. It is 159. It's not, it's x minus 4. Therefore, h is a 4, which means going to the right, because that's positive. 4 to the right. All right. Let's see. Let's put it in our calculator. Yes, but you're responsible for this. Finish up 8, okay? I wish you'd finish it, but you're pretty bright, as long as you're awake. I hope you're awake there. This is being turned in like it was last time. And I need to go to the calculator to see what it looks like. Since I don't know, I'm just going to go graph, graph, graph. I'll go up like that, something like that. It's close enough for government work, okay? It's close enough for government work. What's the domain?
All real numbers.
It is all real numbers. What's the range? What's the lowest you can go? -5. How high can you go?
Infinity.
Well, I got 4 people in here who are doing so good.
Am I one of those?
Well, occasionally. Occasionally you are doing well, but I don't know if you're asleep right now because I didn't hear you answer anything.
Oh, my bad.
As x goes to the right, that's what this means. X is going to the right. Where does it go? Up or down?
Up.
Up forever?
Yep.
Infinity then.
So is there ever gonna be one where it's like not all real numbers?
No. Exponential functions are always, the domain is all real numbers. It's just like a line. A line usually is all real numbers in the domain, unless it's a vertical line. Remember?
Yeah.
So this one can never go straight vertical. So it'll always have some numbers going to infinities, either left or right forever and ever. But it'll always have one of those ends have to go up. If we flip it upside down, it could go down, which I hope one of these will do that. So as I go to the left, this was to the right, I went to infinity. What happens when I go to the left?
Go to
Say it again.
-5.
-5. What was that y-intercept?
-4.
0 and approximately a -4. What's my asymptote? Y equals to what?
-4. No, -5.
-5. See, you're doing it. You're doing good. All right. Oh, good. Finally. Look at the A on this one.
-2.
It's negative. What does negative make it do?
Flip.
It's going to flip upside down. Finally, it's going to flip upside down and be on the other side of the x-axis. If you don't believe me, let's go look at it. I'm going to close. We're going to make my table because we looked at it. We found out at x is 0, it was a -0.125. For those that know their fractions, that's a -1/8. Did anybody find a number as it went down on the right? That would be like a bigger x. Like, look at the table for x equals to 3, 4, 5. Are there any good numbers?
30.
30? What happened at 30? I need something that's in my graph. Okay, so it flipped upside down. My asymptote must still be here at 0 because it never went up or down. So the function looks something like this. As it went from the left, wrong color, it rides the asymptote underneath it, and it's going to hit right under the 0. I would like to have a number that's this way. Can I have an ordered pair that's over here, please? Go to your calculator. Give me one.
3 -8.
Oh, I love it. 3 -8, guys. Let's find it. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Look at that. It's at the bottom of my circle. I love it. There it goes. Look at that. Not too bad. Okay. The hard question, the hardest question of the day. What is the domain?
All real numbers.
Oh my gosh, that's getting so boring. What's the range?
All real numbers.
No,
I'm not going to say anything.
Uh,
I want to see if you figure it out.
it's a -2.
That's not a range.
Hold up.
and it's 0.
Zero. Zero.
0.
Infinity.
There's probably some sort of infinity there, yes.
-0 and
Zero.
no.
Say it again.
0 and infinity.
0 to infinity.
That's
That
what
would
I
mean it starts at 0 and goes up forever.
Wait, 0 -infinity.
said. That's what I said.
0.
Perfect. Except we always go from the lowest to the highest. Good job, Luke. Negative infinity up to where? 0. Good job, Luke. He was the first one that said negative infinity. That's impressive. As x goes to the right, now I want you to look at it. X is going right. Where is it going?
Infinity. -infinity.
Ah, there it is. It goes to negative infinity. That is good, Elisha.
Thank you.
As x goes to the left, the y's go to where?
0.
Goes to 0. Of course, it's underneath the 0, but so what? It's still going up, trying to approach the 0. And the y-intercept, we wrote it over there.
-0.125.
No, there's no such thing as a -0. We just say 0. Oh, wait. Still 0. -0.125. No, we just say just a 0. Asymptote, y equals to what? Still 0. Wow, man.
Ready, right?
Well, I don't know if we've done anything extra credit yet, but I've heard a lot of good stuff.